Yeah, so one of the things that we're commonly saying is that people have a certain mythology about HSS, whether it be you weren't exposed to it in school, or maybe in your first job you had to think about a project and you're thinking about HSS, and maybe a senior engineer said, oh, you don't want to do that because of these reasons. Some of the other myths are, yeah, it's a great product, I love to use it, but it's really expensive. And while there is a cost difference between HSS and other steel sections, you have to look at the installed cost in order to really get the benefit from it. Just looking at the material cost, like everything else, it's not about the front end cost, it's about the total cost of installation. So you have to look at the big picture.
Yes, I think it's good to check. Always have a comparison with the HSS, especially as you have longer on-brace lengths, because if you start looking at the column in terms of capacity, dollar per capacity, you can have some significant savings in the overall amount of steel that you're using. Because as you add the number of weight saving per foot of a column, let's just say, your original price for the wide flange and the HSS may be comparable, but because of that weight savings, you start to have a lot of efficiencies. So it's just something you need to check before diving in.
And I think there's almost a little bit of a cycle where, an unfortunate cycle where engineers are not exposed to the same amount of education when it comes to designing HSS, and specifically the connections. And so often the connection design is not as efficient as it could be, which means that when the fabricator gets the project and they have to price those designs, they may end up at really a higher number than they should be. And so it kind of feeds this perception that HSS is a really expensive product to use in general. But if you're using best practices and designing the connections, something we're perfectly happy to help you do, then you're going to end up with something that, from an overall cost standpoint, is much more competitive than what a lot of engineers, I think, have come to expect. So, when you look at, connections, there's this tendency to think that all connections to HSS are difficult. Sometimes there are certain connections that can be difficult, but for a lot of simple connections, for example, just a beam to a column, a shear connection, you really can do exactly what you're doing for the vast majority of connections to wide flange columns. Just weld a single shear plate on there and be done with it. In some cases, it's actually easier, right? Because you don't have to deal with any web connections because there aren't any webs. And then there's also, of course, the Shuriken, where we're trying to address some of the concerns that engineers have about connections sometimes being difficult. And so Shuriken was really developed, even before it was an Atlas tube product, to try to make it easier to use HSS, to take away that pain point of having to do welded splices in the field. And the original application was more about splices, but really, anytime you're doing an HSS connection in the field, because it's a closed shape, inherently access can be problematic depending on the connection. So to have a tool that allows you to make connections, whatever the arrangement, using bolts when access is tough, definitely kind of opens up the realm of what applications HSS makes sense for.
Well, when it comes to innovation in the industry, Atlas is definitely the leader there. We're always thinking about what can we do better, what can we do next. The investment in the jumbo mill is a great example of that. To increase our size range to the biggest in the industry, biggest in the world, that's where we're doing things that really change what engineers can do with HSS.
With the jumbo sizes that we now offer, I think they have been around for several years, except that they had to be imported. And there may be kind of this lingering expectation that, okay, well, those sizes exist, but it's probably not applicable to my project because we're not going to ship a boatload of them in, and what are they going to cost to do so? What's the lead time? What's the the risk to the schedule? But Atlas, we opened a new mill about 2 years ago, and we're now producing all of these jumbo sections domestically. So if you have a project where the numbers say that that's a good application, you don't have to worry anymore that you're not going to be able to get it or that it's going to cause problems with the schedule with the project, because they're made right here. So this idea that it's really only a special thing that you use for a special project has kind of gone out the window. It's produced domestically. The mill is running all the time, so the size range is available.
Our Blytheville facility that's primarily focused on manufacturing the jumbo sections is strategically located close to a electric arc furnace mill manufacturing the more economical recycled content steel that we use for the jumbo sections. So we're utilizing the most efficient coils possible.
So recycled content is very high in electric arc furnace material, and so therefore HSS that is produced from electric arc furnace has that recycled content, which leads to the lower embodied carbon. And then you add on the other benefits of using less steel. So when HSS is designed efficiently and you use less steel in your project, not only are you using the best steel, but you're using less of it.
There's a lot of math when you're looking at embodied carbon in a building and choosing materials, but I think often in that comparison between materials, what sometimes gets lost is the amount of something that you're using. Obviously it's going to vary by application, but there are times when you're going to be saving a dramatic amount of weight by using more efficient members, especially in the columns, and that's going to potentially have a dramatic impact on the amount of embodied carbon in the structure.
Whenever you're using something that weighs less, it's going to have a knock-on effect to other things. If you're using less steel in your steel frame, it's going to take some weight out of it, which could have an impact on your foundation design, which is generally concrete, which is a higher embodied carbon material, so we can take material out of those systems as well too. So it goes back to that core issue of being as efficient as possible in our design, because that's really how we're going to take carbon out of buildings. Yeah, I think one of the things that people don't realize is they have tools at their disposal now. When they come to us and say, well, we don't really evaluate HSS because it takes more time. There are programs out there that actually you can do direct comparison between a wide flange and an HSS column within the software. You have design groups that you pick within the software, and it actually gives you a comparison. And so it's about understanding the tools that you already have and how to take advantage of those to actually do some of these comparisons that we talk to people about. We're not asking you to do any extra work, it's just taking that extra time to maybe do an extra design group within your software and actually do a direct comparison between how the wide flange would perform in your building versus how the HSS would perform.
Another development we're seeing in the industry that's really helpful from an HSS design standpoint is people are using more and more finite element analysis for connections. For wide flange connections, there's this huge volume of research and guidance that's been published, so that if you have a wide flange or similar type of rolled shape, and you've got some force coming into it from an odd direction, an odd location, there's probably some reference that you can look into that's going to give you design guidelines for how to make that connection. Because HSS has not been around as long as rolled shapes and has not been used quite as much, that volume of research is smaller. And so when you have an unusual situation, there may not be the guidance in the code that we're used to seeing. With finite element modeling programs, you don't need to have that specific configuration that maybe there's an equation for in the manual. You can basically build what makes sense based on the loading and know that you're going to get a accurate analysis of that. And so there are a lot of really kind of common sense things that you can do. I think the situation where a lot of engineers run into HSS use is with aesthetic applications, because it's certainly just a cleaner look having a closed square or rectangle compared to a wide flange shape. But even though that's a great application for it, there's certainly a lot of more technical benefits.
I think one area that where HSS probably has a lot of value but is underutilized is we generically call it the industrial sector, and that can be anything from warehouses, which HSS, as we have talked about before, is already very strong in warehouses because of the long, tall columns. But when you get into things like we're starting to see more battery plants being built, chip plants, where they have clean rooms. Those are areas where people are concerned about the cleanliness of what goes on in the structure. Well, HSS, because it doesn't have any ledges, it doesn't collect dust. You can seal the connections and you can do all these things. So we have a lot of engineers that come to us and saying, well, I'm being asked to do a project that I haven't done before, and HSS makes sense. You know, food processing is another area where we see that cleanliness aspect.